Patrick. Yeah, so I want to focus specifically on how do we get the supply of people we need for agricultural R&D in the future. And I want to start by just saying, well, who does agricultural R&D in Australia? And I couldn't find a source of how many people are in agricultural R&D in different sectors, but I've taken as a proxy the percentage of expenditure by different sectors on R&D. And you can see in 1996-97, it was the states that did the major proportion of agricultural R&D. 10 years later, their share, although the total spend had gone up, the state's share of agricultural R&D had declined. And that decline has been taken up by more research being done in universities and actually business doing more research as well. The share of the Commonwealth, that's basically mainly CSIRO, has stayed pretty steady over that 10-year period. So we're seeing a shift in who does research, and particularly the universities have become much bigger players in providing the underpinning agricultural R&D. But what we're also seeing is a disinvestment in agricultural R&D. We see a lot of states and territory governments redirecting their budgets into environmental research, climate change research, or simply cutting the amount of money for agricultural R&D. The national RD&E frameworks, which are being developed at the moment by the Primary Industry, through the Primary Industries Ministerial Council, are in some states being used as an excuse for preemptive action. And that wasn't the intention of these frameworks. They were there to increase the efficiencies in research, to increase collaboration, break down the barriers between those different organizations doing research. But there's no doubt that in some states they have been used for preemptive cutting. There's no assessment at all on what the national impacts of these various declines in capacity actually are, what the consequences will be. It's an uncoordinated cut in agricultural R&D. We also have the potential for further cuts over the next 10 years with the Productivity Commission in its draft report on the RDCs, suggesting that there should be withdrawal of federal funding from the RDCs, and the estimate is that that could be $60 million over 10 years. And basically one of the drivers, as we already heard mentioned this afternoon, is that agriculture is seen by many as a sunset industry. That includes the funders of agricultural R&D, with the exception of the RDCs, but many governments think that agriculture is not where their economies are going, and they want to get the money and research into sectors which they consider will be more important for their economic futures. And yet that belies the importance of agriculture to the Australian economy. These ABARES data for 2001-2009 show that there's been a growth in the total value of agricultural production to about $42 billion in 2009, and that these sectors here are really significant contributors to the economy. A lot of that produce is exported, and these are the ABARES data for a couple of years ago now for the export value of those commodities to the Australian economy. So it's both important in its total value, but also it's an important earner for the country. And we need agricultural R&D in the future. Global food security, when we've got 9 billion people on this planet, it's estimated that to meet that need, we're going to have to grow agricultural production 2.5% per annum at least from now on. That's compound interest. There's a recognition that we need to do that sustainably. Society expects agriculture to not pollute, to use resources efficiently, and to meet other societal expectations about how it impacts on the environment. In order to achieve this, we're going to have to overcome restraints to the growth in that productivity, such as new pests and diseases which will appear. So they are going to make productivity decline unless we deal with them. So we have to overcome these restraints to growth and grow as well. And I'll show you another example of that in a moment. And we have to achieve global food security with less land, less water, competition for energy, and a more variable climate. And it's my belief that only research and development, intensive focus on research and development, and extension out into the farms is actually going to achieve that. And here's another reason why we need it. We've seen graphs like this at several of the sessions in this conference today. This is from the National Grains RD&E framework document that was produced last year. It shows the total factor productivity index for grains, the grains farmers in Australia. And over this whole period from 1997 through to 2007, 30 years, the overall change in total factor productivity for grains, the grains industry, was about 1.9% per annum, which is pretty good. But most of that came in the period through to about the mid-1990s, when the growth was 4.5%. The estimate is, since that time through to a few years ago, actually productivity declined. Part of that may have been the drought, but I think a lot of people now believe that the large investment that we had in agricultural R&D post the Second World War and the long lag times between doing that research and impact on the farm meant that in this period we were living off research probably done in the 60s and 70s. Large disinvestment in the 1980s in agricultural research globally, and we maybe now are seeing the consequences of that. And yet research actually has high rates of returns. These are data from a conference in Melbourne a few weeks ago. I'm not an economist, so I have to accept that the way this has been done is theoretically correct. But basically, using a number of economic models for the period 1953 to 2007, show that the rates of return using a preferred model were about just under 30% per annum for R&D, and even higher for extension. And the range, there's quite a range when you use different models. But these are all consistent with international estimates of the internal rate of return on R&D investment. And indeed, Julian Alston, in a session earlier this afternoon, gave figures for the USA of about 20% internal rate of return. So these aren't too far out from other estimates from other countries. So it's worthwhile investing. You do get good return on every dollar that's invested. But the problem is there are long lags in the uptake of research. This shows the uptake of no-till in southern Australia, and you can see that the early adopters were using no-till in about the mid-1970s. But it's even now, over 20 years later, only 60% of farmers who could adopt no-till have adopted it. And the rate of growth is slow. It takes many, many years for an established technique of proven benefit to actually be adopted by a large number of farmers. And that's one of the problems why I think states and governments don't feel they need to invest in agricultural R&D, because they don't see the payoff in the lifetime of governments. It's many, many years later that we get the benefits of agricultural research, dollars spent, or if we don't invest, it will be 20 or 30 years when we realize that, in fact, we should have invested. This is another example of why we need agricultural R&D. This is from a report to the Prime Minister's Science, Engineering and Innovation Council, which was from earlier last month. And what it shows is the grain production needed, or the rates of grain production up to 2006, and the changes that may occur in the future. The green line is what we need to do if we're to feed those 9 billion people in the middle of this century. The blue line is a continuation of current rates of of growth in grain production globally, and we have to jump up to the green line to achieve feeding the 9 billion people. But climate change is estimated, depending on what scenario climate change models are used, will have a modest but nonetheless negative impact on grain production. And in the worst case scenario, it has a really big impact. And so potentially, we have to grow productivity not just from the blue line, but from the black line up to the green line. And that's really a very big challenge. And that's why we need agricultural R&D. And finally, there's a growing recognition that the produce from agriculture, which goes into making our food, will in the future be an important way of intervening in the health of the population. Basically, medical intervention, as we practice it now, is going to be too expensive, and using food to improve people's health is seen as a way of doing that. Again, we don't really understand the relationships between what we grow, how we process it into food, what the meat or grains contain. What do we have to do here to get benefits here? That's another reason why we need agricultural R&D.